We'll hope everyone is back for our next speaker, and help me in welcoming our next speaker, Evadne, to talk us a little bit about macros in Elixir. And I'm going to leave and let her come in. Okay.
Well, hello. I'm guessing the connection is good, is it? Okay. Well, so everybody, good afternoon. And my name is Evadne. And today I'm going to be talking about macros and metaprogramming in Elixir in general. So I'm assuming that everybody has already had some experience with Elixir, and you know where to find documentation, you know where to find common resources. So I'm just going to be talking about the practical side of metaprogramming in general. So when it comes to Elixir metaprogramming, there are 4 key modules in the Elixir documentation that you must review thoroughly. And alphabetically, you got code, you got kernel, you got macro, and the module behavior. So these 4, in my opinion, are the key things that you must review thoroughly, because it will really help you when you have problems that you need to solve on hand. So metaprogramming in Elixir is actually very, very simple, and most of the information is already in the documentation. So I believe the information is documented under quote. So I think it's under kernel special forms quote, and I don't know why it's there. But most of the metaprogramming knowledge actually is under kernel special forms quote. And if you go through this entire page, basically you will have a very good idea of how to metaprogram in Elixir. So obviously I'm assuming that everybody knows that, so I don't have to cover it again. And I'll just explain why and when would you prefer to use metaprogramming than straight direct programming? There are usually several reasons. The first one would be that the usual program that you write isn't really fast enough. And if you were to, instead of writing code that reads data from the database or from the file system, you instead write code that wraps around or embeds the data directly, you could get a faster program at the end of it, or in other words, you get performance improvement. The other use case of macros is to ease maintenance, to reduce your maintenance burden by not having to write duplicative code that simply needs to be written. So I think it's the maintenance point of view that actually makes things a little bit more interesting when it comes to macros. And to explain that, well, whenever you write a Phoenix application, usually you will start writing contexts. And contexts are basically collections of functions that operate within a certain domain of your application. So you may be able to handcraft most of the functions, but at the end of the day, you will have to write primitive functions, basically create, update, and so on. So essentially, you need to write a lot of accessor functions. And in order to do it efficiently, you will want to use some macro algorithms to do it, instead of having to write your own functions repeatedly. because keep in mind, when you write macros, the compiler actually expands the macros into actual code. So if you want, you can actually add type annotations and add type specs to all of your generated code. And then you will be able to enjoy Dialyzer and other tools for static analysis. So I have in front of me an example of the accessors module. So I'll just go through it very quickly. So the first thing you can see is that whenever you see something that uses macros, usually you would see def macro using. So the underscore using underscore macro is a special name used by Elixir. Whenever you write an Elixir program and you do def my module, def module my module do like this. Whenever you do use and you put in use my other module, what the Elixir compiler would do immediately is to find a macro called underscore using underscore in your other module. And basically, if you were to add options, or really it's like this. If you were to add any kind of argument, then this bit information will be passed also to the macro. So keep that in mind. So one key restriction or limitation of Elixir macros is that if you want to use macros, you cannot define a macro and then use the macro in the same module. You need to use different modules because that's just how Elixir is designed. But this is not exactly a bad thing, which I'll cover a while later. So just keep in mind, when you see using, this usually means that there is quite a bit of metaprogramming activity going on. So in a typical macro, what you would see usually is the keyword quote. And you usually see quote and unquote, and then a bunch of quotes and unquotes usually. Or you would see something like quote and find quoted something like this. So then you might ask, what exactly is quote? Well, it goes like this. Quote 1, 2, actual quote 2, 1, 10. Then you see I'm only using a number. So the quoted version of 1 is just 1. But if I were to say quote 2 on my module 2, and then you can see that we got something a little bit different. So this thing is basically a fragment of Elixir's AST or abstract syntax tree. And if you want to learn more, again, you need to refer to the documentation. But when you write macros, essentially, you're leveraging the ability to alter and to manipulate code as a kind of data. So you can see in your AST, you have the target and you have the metadata and you have some kind of function call arguments going on in AST. Okay, let's go back to the example. So what I'm really saying here in this using macro is that first I get, this is a paradigm that you will use a lot. When you're writing a macro, you want to keep a reference to the module that actually contains the macro. Because keep in mind, when you actually are writing code in a quote like this, then this code actually will refer to the module that uses the macro. So let's say if you have a shared function like this, and and you want to call it, then you cannot type underscore module inside the quote, because then this will refer to the module that uses the macro. So instead, you will have to first capture the parent, and then you unquote parent, and then you can require import or do whatever you want, like that. So the other thing to keep in mind is you can basically, in your quote, you don't have to immediately do a def and then function name. You don't have to immediately do a def. You can actually just treat code as data. So in this case, when I'm using, I can actually say, okay, get me all the targets, and for each target, I don't even immediately generate any code. First, I classify the target, depending on whether it's an atom, which in this case actually it means that it's a module. But in Elixir, modules are atoms, or module names are atoms. So in this case, if it's just a module name, then I do unquote parent again, and then generate code for this schema. Otherwise, if there are some options provided, then I would generate code for this schema and the following options. So again, this paradigm can be very useful. Classify the target using code in your macro, and then generate your code accordingly. Also, just wanted to add that if you've got any questions, you can post a question as I go into the live chat, and I'll just check live chat from time to time. Yeah, you don't have to wait until the Q&A section to post your questions. All right. So, okay, there's a Q&A stage. I haven't seen any questions so far. It's empty. So if you got any question, please post it. Okay, back to the macros. So, okay, so as you can see here, we got a generate macro, and this generate macro again captures the color, and grabs the module, and then captures the parent again, and then in my big quote, do a quote, and then I bind these bits. And then I start doing name, get a name from the options, and then get a repo from the options, and then get a search from the options, and then I analyze whether the name is singular or plural, and then I start defining functions. But keep in mind, when you define a function, so look at this, module defines question mark. So this means that in a macro that defines functions, you can actually optionally define functions depending on whether a function has already been defined or not. So this is one way of doing it. Basically, you define the functions at the time of macro invocation. But this is not the only way, and I'll explain shortly. But keep in mind, this basically happens immediately when you're using a macro. And you might or might not want to do that. I'll have an example in a bit. So in this case, I'm just defining a bunch of functions. So I have def unquote something, def unquote something, something. So you may have noticed I don't actually just type out the name of the functions, but instead first I build a binary, and then I turn it into an atom. So this is actually an atom, so list underscore and a plural form of the name of something, and unquote it, and then parentheses. In this case, this function has no arguments. So this will then turn into, will turn into something like list books or whatever. So it will compile into something like this. So this is one way of generating function names if you need to vary the function name. But usually when you're using macros, you're actually just generating functions that vary not in the name, but actually in the arguments. So, well, in this case, you can see you can define multiple functions inside the same if block or inside the same other kind of block. If you want to use a case for something else, that's fine as well. Yeah. So you can basically just do that. And after you've done this, you will end up with basically a whole module that's got correctly, or so to say, appropriately named accessor functions that act as your primitives. So one additional thing to keep in mind is that you don't always have to call macros from macros. You can call functions from macros. And in fact, in Elixir, you can define a function like this. So define a module, and then define a function, and then have the function return a quote, and call that function from another macro. So this is also perfectly legal. The only difference here in practice is that sometimes you want to get the environment of the caller. And if you want to do that, then you have to use a macro. Because when you're calling a function, you actually don't get that information. And again, it'll become relevant pretty soon. Yeah. So in any case, you can see in this case, I've got a little helper function somewhere else, and I'm just calling the helper function from the big macro. All right. So this is one way of using metaprogramming. And I did say that detecting whether a function has been defined and then defining it right away is one way of doing it. But actually, there is another way of doing it. And this happens, for example, if you're writing a library, and for some reason, you want a library to do certain things, but only in certain cases. So in Elixir, for example, in the Elixir source, there is actually an Elixir version of GenServer, and it's not exactly the same as the Erlang version, but there is a special feature inside the Elixir version, which is that if you do use GenServer like that in your module, then you're supposed to write an init function. But the interesting thing is that if you've forgotten to write this function, the GenServer module actually warns you about it. And it's able to do it by combining two things. One is obviously the ability to find out what has been defined by using module defines again. And the other thing actually is ability to run additional code before the module is to be compiled, which you may have noticed. In this case, this macro has a special name, which is before compile. So this is another very interesting and very useful function of Elixir, which is that you can say, I have my module here, and for some reason, before the module is to be compiled, I want to have the Elixir compiler call my other module or something else. So this essentially allows you to generate code after everything else has been done. So why is it important? It's because when the code is evaluated for compilation, it's done from top to bottom. So usually, if you were to write a gen server, you would do use gen server and then do def and you would do something like this: def handle code, def handle info, and so on. So at the time you've used the gen server, is using macro like this. At the time you put this in, nothing else has been written. So in the using macro of gen server, you wouldn't have known exactly what has been done in the module, because usually you would put a use statement in at the very top, or at least close to the top. So instead, what you do, or say what gen server does, is in the use, they put in a before compile bit here, which basically tells the Elixir compiler to backtrack and to call the before compile special macro of gen server again before the code is to be compiled, but that's after all the functions have been defined generally. So in the before compile macro, or really function of gen server, the code can see what functions have actually been defined in a module, and then it will be able to make a conscious decision as to whether to, for example, inject a default implementation of anything, or to raise warnings, or even to raise exceptions. So it is possible to raise exceptions this way. Like you can write a pedantic module, and then you do something like this, and then you say using, and then in the using you say before compile, and then refer to my module again, and then before compile. And in this case, you can say if module defines something, then okay, else raise. You can actually do this. Like you can actually do this if you want to. So essentially, you can enforce certain coding guidelines or certain use patterns just by writing your macros correctly, if you really want to do that. But another thing that is that's interesting is that, keep in mind, in Elixir you usually have behaviors. So gen server, for example, actually is a behavior, so you can do add behavior gen server. But this add thing actually is a module attribute. So if I were to do use gen server, then during compilation, actually, if I were to query the behavior module attribute of this module, I will see gen server in there. So I could then, for example, create some kind of add-on module, and basically this module would have a using macro, and the using macro then will inject a before compile reference, and then the before compile macro will be called, and it will be able to check whether this module has pulling a well-known behavior such as gen server, or maybe gen statem, or maybe gen something else, and then generate the corresponding wrapper accordingly. So this may sound a little bit, out of the blue, but it's actually very useful. For example, if you're using some kind of distributed process supervisor, like Horde, for example, because when you're using Horde, you always interact with the dynamic supervisor as API, and you will have to do something. For example, given this name, transform this name to the locator that I can use to query the process in the distributed registry, and then if the process exists and is alive, return the PID, otherwise start the process, and so on and so on. And the key is that when you actually start a process, you will have to use usually start link, and the convention of start link actually differs between GenServer, GenStadium, and other well-known frameworks. So yeah, that's a way to do it. Okay. So does it really contribute to ease of maintenance? Well, my opinion would be that it depends, but if you use macros sparingly, it should help your work. Okay, so obviously, when you're doing anything, you can overdo it. You can overdo anything. So I do have an example of overdoing something with macros, and this Elixir object-oriented programming is a very good example of the powerfulness of Elixir macros. And there's already been a lightning talk for it already. So it was back in 2016. I'll just show you very quickly. It's got an example here. Import OOP. So again, if you want to use any macro defined in a particular module, you first import a module and then you can use the macros. So the OOP module has got a class macro and a var macro and so on. I'll just tell you that the macros actually wrap around code that interacts with agents, basically. So that's that. But as you can see, by using macros, you can dramatically alter the shape and form of your program. So although this looks like you've overdone it, it doesn't mean that, well, it doesn't mean that it has no value. But anyway, again, we talk about code generation using macros and using Elixir metaprogramming. But there is another very, very valid way of generating code, which is actually using embedded Elixir or EEX. So for example, the Aws Code Gen Project is a project that generates Elixir and Erlang code by using templates. So I believe they use templates. So there is a bunch of templates in this project, and basically what this project does is that it takes the variables and it basically interpolates everything into these embedded Elixir templates, and out comes a bunch of Elixir source code files. So in this case, they're doing it not in one step, but in two steps. But it's not exactly a bad thing, because in this case, you have a full suite of artifacts that you can then package into a library, and you can tweak the files as needed if you wish to. So this is a valid solution if you want to do code generation. All right. So I guess another thing that people usually run into when writing macros is that maybe the macro, after the macro has been written, it doesn't do what you want it to do. And since macros are compiled into something that looks basically entirely different from your source code, it's very difficult to reason about it. So, well, there's only one solution to that, which is to actually dump or to analyze the shape of the generated code. And I have here an example for you. So in this case, I'm going to look at what's generated by getText. So getText is a library in the Elixir core, basically, but it's not part of the Elixir language repository, but it's hosted by Elixir Lang. So what it does is it allows you to very easily implement internationalization and localization in your application. So in your application, you will write something like getText, and then you put the English text in here, or maybe you put something else, and then you integrate a compiler, like so. Your mix.exs, you would put in compilers, getText, and then you add the rest of the compilers. And this allows getText to basically go through all the source files and then analyze and extract the keys into the templates and into the PO files. And at runtime, you can then use this code at runtime, getText hello world, and you will get the localized version of hello world. But here's the thing. getText does not require you to bring additional files. It just compiles everything into the Elixir module, or modules, if you deviate from the default. But you can't see it unless if you were to, do something about it. So that's where this snippet comes in. So what you can do with any module, or almost any module in your application, which either you have written or you had the source code to and you pull down via hex, is that you can use some Erlang codes to basically get the object code of the module, and then you get the chunks, and then you get abstract code, and then you format it and put it out. So I guess I'll try it here. So let's say I got the getText module. It's here. getText work. Okay. Here I have verified that it actually works because I've got an English version here with EN. Okay, so this means that this atom will be a valid module name. So I'll do this. And then I shall get the object code. In this case, I get the module name, I get a binary, and obviously I get the file name. The file name is not really required here. I just want the binary. So then I get the result. And immediately I get a bunch of basically stuff that would make up the module. So then I grab the part that's got the abstract code, and then it looks slightly different, but it's not so much different. And then I basically format it and then put it out. So now I have something that basically resembles an Erlang program or Erlang module, so to say, and whatever macros have done can now be seen pretty easily. So let's find our hello world, shall we? It's here. So as you can see, getText actually compile this bit of information directly into the source, basically directly into the program. So when you call getText at runtime, you don't have to go to the disk. You don't have to retrieve anything from the internet. It's basically just embedded in the function. And more importantly, the function knows what to return because the function utilizes pattern matching. So in this case, if the input term is hello world, then, and in this case there are no bindings, then return hello world English version. So again, this paradigm here is very important and will be seen a lot when you start writing a lot of macros, which is that macros can be used to generate stuff that you can then deal with normally with pattern matching. So as you can see, there are 3 function heads, and basically the names are the same, but the arguments aren't. So again, pattern match. So this happens a lot. All right. So far, there are no questions. Okay. All right. I think now we can look at another more involved example, but before then, I'll take a look at another pattern. So this is from a library called Etso, and in this case, you're just organizing code. So by organizing, what I'm really saying is that, for example, when you're implementing an active adapter, you not only have to conform to one behavior, you have to conform to multiple behaviors. So like active adapter schema, and active adapter queryable. So you may end up with a single file which is very large, or you could try and break the file into multiple pieces, but then you'll just have to find a way to put it all into the same module. So what you can do is basically something like this, which is, again, a little bit of meta-programming. So this bit. What this bit really does is that first you specify 2 modules, and then for each module, you look at the information of its functions, and then you know for each function what's the name and what's the arity, and then you know the number of arguments. Again, keep in mind that you can then basically generate a bunch of arguments like this. And what this thing really does is, say arity is 0, then the arguments would be like this, which is kind of buggy. But if arity is 1, it works. Arity 2, it works. I believe you can go up to like 255 or so. The number of arguments. I think it was limited internally in Erlang, but I don't know how it is like now. But you can generate basically a bunch of arguments. But obviously, the problem with this is that, well, we know already you can generate the name of the function pretty easily by doing an unquote and put the name in, and then you can just put an atom in there or generate your own atom. But how about the number of arguments? So this is where the unquote splicing function comes in. Actually, this is a special thing in that it splices this list into the arguments. So by doing this, you can essentially generate, basically you would just generate knife and then you would arc1, arc2, arc3, and so on. You would just generate something like this. And this is really, really very useful because now it allows you to split implementation across different files. Okay. Okay, so right now I have got a question, which is, okay, let me read it. Classically, in the Elixir community, the general advice is to avoid macros. Do you have any recommendations on when it is a good idea to ignore that advice? Have you ever regretted macroing? So it's not only just one question, it's multiple questions. Well, I would say that it depends on, first, how many people are expected to maintain your programs, to how frequently do you expect to touch your programs, and 3, do you think that using macros is going to save you any time at all in the long run? So again, people would say the solution to pollution is dilution. And in the same vein, basically, the solution to syntactic sugar is to just sprinkle it around and not go overboard in any single module. So, don't go overboard like, solving the problem of 8 queens using just the type system or something like that. You don't have to do that, but just, use it in moderation. So, for example, in this case, the alternative to, splitting the implementation across multiple files is that I now have to write everything in the same file. And doing it all in the same file isn't exactly bad, but it makes the file larger. It makes the file so large. I know in certain cases, certain projects have resorted to having a certain module act as the documentation module, but then they actually write the code somewhere else because otherwise it's going to be too big. So it happens. And you need to be able to manage complexity in smaller chunks. And if macros help you do that, then I guess it's useful. Just make sure that you can actually read what you've written, the day before, and don't go overboard. That's very important. As to whether I've got any regrets, I would say yes, I regret a lot of my decisions. But on the other hand, whenever I realize that I made a mistake, I can always fix it the second day or so. So it's never a big enough problem, so to say. Okay. Anyway, in this case, you can see, let's move it. Okay. Basically, by using metaprogramming, I can then, move certain logic into some file, and now I can just refer to the file side by side. By the way, there is an additional thing that I have noticed in Elixir, which is that when you're writing a module, like for example, my Gen server, and then you do def handle call, and then handle call, and then you do handle info. If you then write handle call again, Elixir will warn you that you put this function in the wrong place. But the thing is, I think this is new, relatively new. If you were to, include these functions from one module, and then these functions from another module, and so on, just by basically lumping them all into the same module using this paradigm, then Elixir used to warn you about it, but it no longer does it, I think, from 1.11. And I don't know whether it's intentional or not, but keep that in mind. So this doesn't throw warnings anymore. Okay. Right. So I think we have time to look at one last substantial example of basically macros. And I'm just going to pull it up here. So another reason to use macros is, for example, you have any kind of input which is complicated or relatively expensive to parse, but very cheap to handle once you've converted it into some kind of intermediate representation. And this happens, for example, if you're writing a firewall. Why? Because when you're writing firewall rules, you actually do something, write something called CIDRs. So you wouldn't say 192.168.1.1 to 192.168.1.5. You would just say 192.168.1.1, or you just say 0. I think it's something like this. So you just write an IP address, which is the first address, and then you put in mask here. So this is called a CIDR. It actually refers to a range of IP addresses. And the problem is that it's kind of expensive to handle. If you're writing rules, it's easy to write and it's easy to understand. But for a computer to work out whether an IP address actually falls under the allowed or denied range, it's actually quite expensive. So in this case, you might want to use a macro to basically mount it at compilation time if you want to. Okay, so let's look at the firewall example. So this is a firewall, or say a DSL. So what it allows you to do is basically define a module and then pull in the builder. And you can say, I want to handle this preset of IPv6, embed IPv6 addresses. And then for this preset, which is a bunch of instance metadata endpoint hosts, I would just reject them, and so on and so on. So this is what judicious use of macros can give you. Basically, you can define your own DSL, but just keep in mind that if you have invented your own DSL, you will have to document it and you will have to teach others about it in order for it to be useful. So the more you do, the more you define, the more you deviate, the more you have to educate. So just keep that in mind. But anyway, let's just look at it. So when you start doing this kind of DSLs, there are some paradigms around how to do it. So the first one would be to pass around a struct that you don't see, a private struct. So each call actually works on some kind of private struct, and you just pipe it down. So the other kind would be to just specify what you want, but not commit to anything until, again, the module is ready for compilation. Remember, before compile. So especially in case of firewall systems, you actually want to do that. You want to delay compilation as much as possible, or delay evaluation, because you want to know whether there is some kind of fallback rule for the unmatched cases. For example, if in the firewall I say reject this, so how about the rest of IPv4 addresses? Do I accept them? Do I not accept them? And you wouldn't know the user's intention until you've looked at every rule. In certain cases, the user may even mix the v4 and v6 rules, and they might not always order them in the right order, or even order them at all, or cluster them properly. So you will want to basically just allow the user to do whatever they want to do, and before compilation, reorganize everything. So how do you do that? Again, the answer lies in module attributes. So there are multiple ways to keep state during compilation. Just keep in mind, during compilation, you can still use Elixir code, and you can basically use agents and so on. And even in XUnit, I believe XUnit files actually do require an active XUnit server to be running in order to actually get compiled. But in this case, you can just accumulate everything in module attributes. So in this case, when I use the builder module, I can just say, okay, def macro using, in this case, import all the helper functions and macros, and then before compile, call me again, and conform this module to this behavior, in this case, a provider, and then make a module attribute, which is the empty list. And before compiling the code, I get the environment. So I just want to know the module. So env module, and then I just want to get the attributes of reverse rules and then reverse it again and then build. So this is just, just how Elixir and on does it, the lists, because you can append you can prepend something to a list pretty cheaply. So you can just keep on prepending and prepending, and then once you're done, and when you're ready, just reverse it one time. So as you can see in this case, the accept keyword, accept, reject, and handle, these keywords are actually macros, but these macros are only macros because I need to know who the caller is. And basically target, get a target, get a caller, and then put a rule into the module attribute. So these macros actually don't do anything other than storing data. The actual generation of code actually doesn't happen until we hit before compile. And this is very important because then this allows the file system to insert any kind of fallback handling as necessary. So in this case, put target rules. Okay, we know what target it is and what action it is, and there are some arguments. And just generate a rule and put it in the module attribute. Again, put it in the module attribute and don't touch it until the code or say the module is ready for compilation. So in this case, get all the rules, reverse them so they're the right way around, and then build. And when building, again, keep in mind what we have just seen. In a big quote, you can have multiple blocks. So you can essentially treat the contents as a list, and then you just add stuff to it. So when you're building something, you can just build a list. And then you put down a block here, a block here, and a block here, and the Elixir compiler does the right thing for you. So in this case, again, as I mentioned, in Elixir 1.11, it actually stopped complaining about interleaving the function heads, I believe. But in this case, we're just using the headers for IP. So it doesn't trigger that. Just put in the function headers. In this case, pattern match. If it's v4, then go to the internal v4 function. Otherwise, go to the internal v6 function. And then for every rule, build a rule function. And then finally, build the fallbacks. If there hasn't been a fallback specified by the customer. For example, if I would say reject this, which means reject all the 4 arity tuples, and in this case, it means reject all the IPv4s, then I would have had a fallback already, so another fallback doesn't need to be generated. Yeah, so you can generate code optionally, like this. Okay, and again, you have accumulated all the rules in the module attributes. So for each rule, you have to classify the rule. So by classifying, you will either classify it as in this case, a firewall system, you'll classify it as a pattern rule, and pattern is URI, or it's something else, or maybe it's a range rule, or so on. And just pay close attention. You can actually use unquote for guard clauses, which means that you can say, so in this case, guard. The guard clause actually can be part of the generated code. So this thing actually would compile to something with a guard clause. Okay. It's probably more interesting to see it actually in action. We do, but we don't have a lot of time. Okay, we don't have additional questions so far. Okay, let's do it then. Okay, I already have this, so I guess I will just do a little bit of shown like this. Okay, it's been compiled. So yeah, I wrote a IEX.exs file to pull in this. So as you can see, the stuff compiles into verify IP, and if it's IPv4, then verify IPv4, otherwise verify IPv6. But it also does a two-value call to convert the 4 or 8 arity tuples to an integer, non-negative integer, which is the underlying value. And just to add, verify IPv4 and v6, they both have both the tuple form and the number form in their arguments. This is so you can do ranges using the second argument, and you can do pattern matches using the first argument because guard clauses are interleaved. So again, this would be how it looks like. All right. So I don't see any further questions so far. Okay. There's something in the chat. Okay. Then I guess I better wrap it up. So if you wish to do more metaprogramming, and if you wish to learn more about metaprogramming, then indeed you can read the Metaprogramming Elixir book, which is a very, very nice one. So I think second edition, no, first edition. This is actually a very, very nice book, and I do highly recommend it. And in addition, obviously, in the Elixir documentation and the Elixir website, you can find additional documentation and information on how to write macros. And obviously people would always tell you to write macros responsibly and to be mindful of hygiene. Well, you know how it is. Okay. Well, thanks everybody for your time today. And please let me know if you've got any additional questions.